this section, we've got a linear inequality involves a linear expression such as y equals mx plus b, but instead of the equal sign it has less than, greater than, or less than or equal to, or greater than or equal to. Inequalities are super tricky though, because I know that my husband called me last week. He's at work, he's writing a report. He works for FedEx operations and they have to have a certain number of packages come through. And so he was trying to say, okay, we need to have 50 packages at this time, and we need to have 50 packages or more. Which direction does the inequality go? And he sent me a screenshot and everything, and I had to correct him. He had it going backwards. He wanted the stuff to be more than 50. So he put his stuff, and then he has to put 50 here. But he had it backwards. So I get it. It's kind of a tricky concept. The alligator eats the bigger one. So when we read that, the result is a graph that has shading. Which way is the shading? It says right here the shading is above the line for what? For y is, how do we say that? The alligator's eating the y. So if it's eating it, it's bigger. So Cooper, how do we say this? Y is what? How do we say that part that I've highlighted?
Sorry.
I gotcha. So when the alligator is eating it, the alligator only eats the thing that's big. So how do we say that inequality? Y is what? That's right. So for y is greater than, and for y is, and how do we say this one, Ryan? That's right. So for the greater than or the greater than or equal to, which way do we shade? What does it say? Above the line. That makes sense. We shade for the bigger side. And because we're going to have a line, we're going to shade above or below. Below makes sense with less, right? Above makes sense with more. And so that's how this works. So we're going to have the line on the graph, and we're going to have to shade. And that's kind of what we saw on those pictures. Remember, he had the shading, and we saw the shading. So the solutions to the inequality are in the shaded area. And we're going to play with some inequalities on the next screen. So here we've got the inequalities, and I can see right now it's purple because they're overlapping. So when I say play with them, I've got y is greater than 2x, and I have y is greater than or equal to 2x. So what I notice is that they overlap each other. So when I click on the blue one, all that's left is the red one. So I see that it's shaded above, and I notice that the line looks broken. That's a dashed line. It has the dashed line with what inequality symbol? Y'all see it? What's the symbol there? Greater than. So it's greater than, it has the dashed line. And I'm going to add in, I want you guys to click the plus. We're going to add in a note. For the greater than, oops, THE symbol, use a dashed line. Okay, that dashed line represents an open circle line. Remember when you would graph inequalities and you put an open circle? That's what this means. What's important about this is numbers on the dashed line are not solutions. Where are the solutions? They're in the shaded area, but sometimes you'll have a solution that's it's right on the line. So if it's right on the line, that's the open circle. And so it doesn't make sense because it represents 0 is greater than 0. And that's false. 0 is not greater than 0. It has a different relationship. What's the relationship between 0 and 0? 0 is what compared to 0?
Equal to.
Thank you. 0 is equal to 0. Perfect. So when I turn off the red one, I'm going to turn on the blue one. So when I look back at this graph, I'm looking at it. It's the exact same graph as before. There's one difference. Do you guys notice the difference? You can look at your screen. If you click on it, it'll turn on versus off. So if you just turn on the blue, what happens? No more dashed line. What kind of line do we have? We have a straight, regular, normal line. I'm going to call that a solid line from now on. And we want to make a note too. So we're going to click plus. We're going to add in a note. And I want to move this note down to the bottom. So you see how I can do that? And this is great practice because we're going to be doing this on our project. So for the greater than or equal to, see how I just put both? That's what we have to do. We use a solid or regular line. Now, would it make sense that answers are solutions here? Now, 0 greater than, wait, that doesn't look like 0. 0 greater than or equal to 0. Is that true or false? 0 is greater than or equal to 0? Is it true or false? It's true. The word or means one or the other. They don't both have to be true. So since equal to is true, then it means that this one is true. And is they both have to be true. So that means that solutions on the solid line are solutions. So this is kind of a really weird thing. I spelled solutions wrong. So here you're just looking, I see that these equations look very similar to each other. I do see that its y is less than negative 1/3 x plus 5, and y is less than or equal to 1/3 x plus 5. So I just want you to add in the notes of what is similar, and then add in a note about what is different. And that's all you have to do on this slide. So, the slope. What is our slope this time? That's right. That's down 3 and to the right 2. And our b value is 0, 0,4. So to graph this, we start at 0, 4 on the y-axis. We count down 3 and over 2. And just like normal, we're going to sketch the line by plotting those dots, and I want you to do the same. And then we're going to take a pause, and we're going to look more closely at this symbol. So it says y is greater than. So for this one, greater than, are we going to shade above or below? Okay, greater than. Greater than. Does that seem like more or does that seem like less? Samantha, greater than. More or less? More. More. Does that sound like above or does that sound like below? Above. So we're going to shade above. We also need to decide how to graph this line. So it does not have the line underneath it. If it has the line underneath it, then we graph a regular line. That's the hint it tells us in the equation. So this does not have the line, so we do not graph a regular line. What kind of line do we graph? It's not a regular line. What kind of line would it be? You guys can look back to see what did they look like before? Dashed. We're going to do a dashed line. Uh-oh. So I'm going to connect my dots with a dashed line. I'm going to shade above. And so these are my solutions, all in the shaded area. So then I want to look at my multiple choice, and I'm going to write those ordered pairs down. So take a minute and sketch this. 0, the origin. The origin is clearly not in the shaded region, so it's not a solution, right? You guys can agree with that? 0, 4 is on the dotted line. So is on the dotted line a solution or not a solution? Not a solution. 5, 5, it's in the shaded region. Is it a solution or not a solution? That's a solution. So I collect that one. And then -5, -5, it's in the white area. Is it a solution or not a solution? The one on the line, because it's on the dotted line, is not a solution. It will be a solution if it's on the solid line. So here we have graphed example number 6. Let's take a look at graphing example number 7. So this one was the exact same line. It was greater than or equal to. Number 7 is the exact same line, but it is less than. So how is this one going to be similar? How's it going to be different? What kind of line are we going to have here, class? Solid or dashed? Dashed. And are we going to shade above or below? Oh man, my pen just does the craziest stuff. So that's what I want you to do right now. Yeah, so from here we can see we all started at 0, 4. We went down 3 and over 2, and you can see the overlapping dotted lines. We shaded below for y is less than. 0, 0 is the solution, and -5, -5 is the solution. But 0, 4 on the dotted line is not a solution, and neither is 5, 5. Here's our last one with the exact same line. I see you guys are already getting started and looking really good. Same line as before. This time it's clearly a solid line because it has the line underneath it has that underline. Underline means it's a line. And this time 0, 0 is a solution. That's right, 0, 4 is a solution on the solid line. And -5, -5 is a solution. So great job so far on this. So when I look at this, you try it, I see that the slope is 2, the y-intercept is -1, and it says y is less than or equal to. And so for less than, we shade below the line. And since I have the underline, I do have a solid line. So I have a solid line and I shade below the line. Solid line and I shade below the line. So that's underline means solid line. Less than means below. That's enough information. And so when I go to graph it, I start at -1. I count up to and over 1. Remember, that's 2 over 1 as the slope with a solid line. And I shade underneath the line. Okay, so here's our example. We had y is greater than -x plus 8. We started at 8 on the y-axis. We went down 1 over 1. I see that somebody started at 7. Bad counting, but pretty good. And we shaded above. So we had a dashed line, and we shaded above the line, and this looks perfect. So you looked at those 12 and 13. You played with the sliders. So it's x is less than or equal to 4. How would you draw this line? And how would you shade? So you might want to look back at 12 and 13 to determine. X is a vertical line. Am I going to do solid or dashed? For x is greater than -3. Dashed. Click, 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 click. Greater than -3. Is 0 greater than -3? Bigger than -3. Is 0 bigger than -3? Is it? Yes. So I'm shading in blue here. Then in red. Good morning. So to change it to red, I just click here and I pick red. Y is less than or equal to 6. So here's y is 6. Horizontal or vertical? Hadley, horizontal or vertical for y is less than or equal to 6? Horizontal is correct. Solid or dash, Samantha? For y is less than or equal to 6. Slide 16. Solid is right. And we know that it's solid because why? It has that underline. It has the equal to. And are we going to shade above or below?